happening. Let me just check this. Thought I had gone live here. It says you're live, but I'm not able to see the live thing on the website. Give me a second, I'm just checking this out. It should have been live by now. Something is going on. Please do tell me on the feedback that you can all see me live. Not happening, not happening. Yep, wonderful, wonderful. Wonderful, I hope you can all see me and hear me now. Please do confirm that you can indeed see me and hear me. I want to make sure that there's a tech confirmation happens. Please type in the chat window that you can see me and hear me clearly. I'm going to get the tech part super confirmed and clear before we go any further. Okay. Use your paper. Lovely. Anjit Kumar says yes. Lovely, lovely, lovely. Good afternoon to all of you. Good afternoon. We're going to discuss permutation probability questions from across CAT papers. We're going to discuss 2021, 2020, 19, 18, 17. Hopefully, we'll see how far we can go. The couple of years, last 2 years, there were 3 papers each, so 6 papers there. 3 years before that, there were 2 papers each. So we have 12 papers with us totally, for which the content has been released and everything is fine. Volume is slow. AV is clear, people are saying. I think Cube 7, you might want to check whether the audio is good. Abhishek says, kudos, taking classes since 99. Many thanks, many thanks, many thanks. I was tired at the end of the second session, but now I'm happy. These are beautiful questions. I later realized that I had underestimated these questions, so now I need to. It's not audible. Audio is low. I will check that. Give me a second. That amp thing has gone on. Hello. I will keep speaking. To make sure audio low to can't hear. We are fixing that. We're tickling. We are basically doing one round of tech checks. Let me put this back on so that there's no bias for that. Hello. We should be good to go. Audio should be fine. Please confirm that audio low to can't hear. It should be fine. I've been poking around with this. It should be fine. I'm going to wait for maybe a minute and a half for confirmation. We're not too late. We can start at 3:05, not the end of the world. Please do confirm that the audio issue has indeed been fixed. If it has been fixed, then we are good to go and I'll be happy. No, perfect. Thanks, Abhishek. That is lovely to see, especially in this context where there is a time lag. There is a certain lag between when we speak and when you guys listen. Right? Harsh Tosi, to those who audio is low, I recommend using earphones. Earphones, perfect. I think earphones work better per se, but I think the audio issue, there was an audio issue, it has been fixed. Fine. And I will be louder as well. Fine, super. Cube 7 says perfect. Lovely. Wonderful. I'm gonna not prattle on for too long. Jump into these questions. I'm gonna give maybe a minute and a half. You guys should digest these questions. Give them a crack. In the meanwhile, I'm gonna keep prattling on so that there's no, so you don't get bored. So permutation probability is a super fun topic. It's a super interesting topic, but it is not a heavily tested topic. It simply is not a heavily tested topic. I realized it more so when I went through the papers, went through the last 12 papers, which are officially available. And I could find only maybe a very few papers where there is more than one question. And very often the more than one question is, I had to do kind of a little bit of cheating to bring them into permutation probability. There are questions in algebra, questions with x's and y's thrown in. How many integer solutions exist, which are practically not permutation probability questions, they're just algebra questions, which I then kind of renamed as permutation probability questions to bring them back in here. So I did do that a little bit of a fudge. So generally, whether it's a 2-hour paper or a 3-hour paper, you get one question from permutation probability, usually. So 1 out of 24, 25, 26, or 1 out of 33, 34 questions come from this topic. Not heavily tested at all, and most, very often, very intuitively done. A couple of times are super tough, super challenging, but frequently not super tough and doable intuitively without knowing what is the value of 10C3 by 11C5. And so I'm going to keep prattling on. I'm going to make this into a kind of 2-part session. one where I'm talking and filling the gap whilst most of you are trying these questions, and then leave you with a framework and then attack these questions, solve them completely. And I think we have about 18 to 20 questions with us. Let's see if we can squeeze a few or most of them within like a 1 hour, 1.5 hour window. Right. Lovely. Let's jump in. Audio is good, video is good. Try this question. The number of groups of 3 or more distinct numbers that can be chosen from 1, 2, 3, 4, 5, 6, 7, 8, so that the groups always include 3 and 5, while 7 and 8 are never included together. It's a beautiful question. So we have, let me see if I have a marker here. Yeah. We have 1, 2, 3, 4, 5, 6, 7, 8. From this, we need to have sets of 3 or more. 3 and 4 are always in. Right? And I made a mistake. When I read this question for the first time, I said, look, what a silly question, nothing challenging here. But it said 7 and 8 are never included. 3 and 4 are always in. 7 and 8 are never included, not rocket science. Let's take it in. 7 and 8 are never included together. So it's very interesting, never included together. And that part, the together thing, I didn't read properly. Kind of got it wrong and had to reconfigure that. Right? So nice, beautiful. So 3 and 4 are always in, and 7 and 8 are never included together. So if I have 3, 4, 1, 6, that will get counted. 3, 4, 5, 7, that will get counted. 3, 4, 7, 8, that won't get counted. Nice and simple. Let's get the framework going. What is counted, what is not counted? 3 and 4 are always in. 7 and 8 could be in individually, not in together. We cannot have 7 and 8. We can have 7 only, we can have 8 only. We cannot have 7 and 8. Right? First of all, 3 and 4 are always in, so I'm going to just remove 3 and 4 from the equation. So I'm dealing with only 1, 2, 5, 6, 7, 8. And from this, I want to find every subset that is one element or more. These two are always in. Totally number of elements should be 3 or more, of which I'm including 3, 4 already. So out of 1, 2, 5, 6, 7, 8, at least one should be there. So I can select one or not select one, 2 in or out, 5 in or out, 6 in or out, 7 in or out, 8 in or out. So totally, if I didn't have this 7, 8 condition, there are 2 power 6 minus 1 subsets possible. Why 2 power 6? 1 is in or out, 2 is in or out, 5 is in or out, 6 is in or out, 7 in or out, 8 in or out. Each thing we have 2 states, in or out, effectively counting subsets by thinking, is it in or is it out? Why minus 1? The scenario where all of them are out will result in a subset just having 3 or 4. I need to have subsets that have 3 or more distinct numbers. So 2 power 6 minus 1, 2 power 6 is 64. 63 are here. But remember, this includes a bunch of subsets that have 7 and 8 in them. I want to subtract that. What do I want to subtract? First of all, let me remove these fellows completely. I've done the framework. So 63 are in here. From this, I need to subtract all subsets that have 7 or 8, already sitting inside. 7 and 8 together. 3 and 4 are there, so all subsets that have 3, 4, 7, 8. 3, 4 I have removed from the system, so I'm thinking only about 7 or 8. 7 or 8 are there. What are the remaining part? 1, 2, 5, 6. Out of each of these, 1 could be in or out, 2 could be in or out, 5 in or out, 6 in or out, or 2 power 4 possibilities are there. There are 2 power 4 subsets of 3 elements or more that have 3, 4 in them and 7, 8 in them. There are 63 subsets of 3 elements or more that have 3, 4 in them. From this 63, if I subtract the 16, I've got my answer. 63 minus 16 is 47. Bunch of simple things to note here. We're saying counting subsets. So each element we think of it as, look, 1 could be in the subset or out of it. 2 possible states for 1. 2 could be in or out. 3, 5 could be in or out. So there are 6 elements, totally 2 power 6 combinations are there. Of which there's one combination where none of these is selected. I'll remove that. Because if none of these is selected, then I have only 3 and 4. Then I'll end up having a 2 element subset. which has 3 or more distinct elements. So 2 power 6 minus 1 gives me a sum total of all subsets of this 1, 2, 3, 4, 5, 6, 7, 8 that have 3 and 4 in them and at least one more element in them. 63 in the bag. From here we have to remove everything that has 7 and 8 in them, or I'll have to remove everything that has 3, 4, 7, 8. 3, 4, 7, 8 are definitely in. I'm worrying only about 1, 2, 5, 6. Each of them could be in or out, in or out, in or out. 2 power 4 possibilities. Subtract this 16 from that 63, 47, done. The other way of doing this is have 1, 2, 3, 4, 5, 6, 7, 8. Count subsets that have 3 and 4 in them. No 7, no 8. 3 and 4 in them. 7, no 8. 3 and 4 in them. 8, no 7. And then see if we can kind of combine these in some form effectively and see how many possibilities exist totally. So 3, 4 in them, no 7, no 8. 3, 4, 7 in them, no 8. 3, 4, 8 in them, no 7. And then see where that takes us. Add all of these up. We should be through. 3, 4, 7 in them, no 8. The remaining 4 in or out, in or out, in or out. 2 power 4 subsets. 3, 4, 8 in them, in or out, in or out. 2 power 4 subsets. 3, 4 in them. 1, 2, 5, 6. Each one in or out, in or out, in or out. 2 power 4. But none of them being there, that shouldn't get counted. 2 power 4 minus 1. 15 plus 16 plus 16, 47. Beautiful question, really challenging. N elements in a set, how many subsets are there? 2 power n. This 2 power n includes the whole set and includes the null set. Every element being considered gets counted. Every element being not considered, there's no element being counted, that also gets counted. So every time we need to make an adjustment for one or the other of this, we need to make that. Right? Lovely. Three and 5. Oh, I got the entire question detail wrong. It is 3 and 5, while 7 and 8 are. This old saying that all the novels written by William Shakespeare were not written by William Shakespeare, but by a guy who was not William Shakespeare, but just called himself William Shakespeare. A rose is a rose is a rose. So with the funda idea, everything remains the same. So I've effectively solved this question for this being 3 and 5. 3 and 4, not the end of the world, funda idea. I'm not going to resolve this to make that adjustment. I'm surely not going to resolve this. The funda concept ideas are all exactly the same. I got that non-punishing detail wrong, so pardon me for that. Right? So I explain the in or out method. So nice. So suppose I have an element which has a set which has A, B, C, D, E. I want to find how many subsets are there. So I call a subset. It's almost like I have A, B, C, D, E with me, and I'm creating this subset. I look at A and then say, look, do I really want A? Yeah, maybe I want it, or maybe I don't want it. I might put it in, or I might put it out. So A can go in, or can get kicked out. B can go in, or can get kicked out. C can go in, or can get kicked out. D, E. Each element could be part of the subset, or can get thrown out. 2 into 2 into 2 into 2 into 2. Each element has 2 states. It may be part of the subset or it may be sitting outside. So 2 power 5 combination. This 2 power 5, remember, just one thing to remember, 2 power 5 includes the null set, nothing being selected. It includes the overall set, the improper subset, A, B, C, D, E, all of them sitting inside. Some questions will ask us to eliminate one or eliminate the other or keep that in mind. That alone we need to be careful about. Lovely. Lovely. Let's go to the next one. Again, give this a go. Have a crack at it. I'm going to give about 30 seconds for you guys to kind of digest the question and take it in and see if it makes sense. And then I'll attack it. Meanwhile, I'm having one look at the chat window as well. Two power 4 minus 1, why do we not take that? We do take that. We're adding the second method, we're adding 2 power 4, and then 2 power 4 minus 1. 16 plus 16 plus 15. 32 plus 15, 47. That's what we're doing. We're doing it by two methods. One is to count everything and then remove everything where 7 and 8 are present. Or count everything where there's no 7, no 8. Count everything where there's 7 but no 8. 8 but not 7 and add everything up. Lovely, I'm going to attack this one. How many 3-digit numbers are greater than 100? All 3-digit numbers are greater than 100, so that is superfluous. And increased by 198 when the 3 digits are arranged in reverse order. And 3-digit number ABC is 100A plus 10B plus C. CBA is 100C plus 10B plus A. Goes to here, it increases by 198. Or if I subtract this, if I subtract 100A plus 10B plus C, then I get 198. In other words, 99C minus 99A equals 198. This disappears completely. Or C minus A is 2. My units place is 2 more than my hundreds place. C is units place. It is 2 more than the number in my hundreds place. Or what am I looking at? I'm looking at a number like 143. 2 more. Or 2-4. Or 3-5. Something like this. Right? So now I've got the hang of this. I know my units place digit has to be 2 more than the digit on my hundreds place. Good, in the bag. Now I need to count. So what are my units in hundred place could be? It could be 1-3, 2-4, 3-5, 4-6, till 7-9. All of these. Now let's go to 1-3. What could this digit be? My B can be anything. My B could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Anything. So I could have 103, 113, 123, 133, all the way till 193. Everything is possible. All of the digits are possible. So there are 10 numbers here. Likewise 10 here, 10 here, all the way till here, 10. 7 possibilities, each having 10 numbers. 7 into 10. Excellent question. Very doable. It helps if you know that funda that a 3-digit number and the number formed by reversing its digits is 99 times C minus A. If you can get that, it is super easy. That means that units place is 2 more than the hundreds place. So it could be 1-3, 2-4, 3-5, all the way till 7-9. 7 sets, each set of 10 numbers, 7 into 10, 70, game over, done. Om Singh saying 7, not just 7, my friend, 70. Each of these things, there are 10 possibilities. So 7 into 10, 70. We have one element of kind of number systems, number theory, and then one element of counting. Counting part is how many values can B take. B can take value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 possibilities for each combination of AC. 7 combination, 7 into 10, 70. Lovely. Super, I'm just having one look at the chat window. Nothing dramatic happening there. I'm going to go back here. Super tough question, super tough question. It's a lovely, challenging, beautiful, tough question. So try this, give it a go. I'm going to talk about something else. I'm going to answer some questions on preparation strategy, which have been asked here. I'm going to use these gaps to discuss that. Right, so Prithvi is saying, is it still possible to prepare for CAT 2022? Most definitely, yes. And so 5.5 months, 6 months is ample time. You're on June 15, July, August, September, October, November. November 20th takes 5 months. Little more than 5 months, very much possible. Is it going to be easy? No. The number of hours you're looking for in the ballpark of 300 to 400 hours. You can squeeze that out of 5 months merrily. You're looking at 15 to 20 hours per week. Yeah, doable. Adding another 20 hours per week on top of your college or work life, is it easy? Of course not. Whoever said good things come easy. So hang in there, have a crack. It should be possible. So it is very much possible to prepare with that in mind, with the framework which squeezes you a lot. It takes the happiness out of you for the next 5-6 months. But the best way to take that, not happiness out of you, you can prepare very happily for this exam. Sorry for apologies for my poor choice of words. So it doesn't take the happiness out of you. It takes the frills out of Netflix and Hotstar and Prime and all kinds of junk on YouTube. So we stop going down YouTube rabbit holes. That right there is 70 hours for the next 5 months. Dig into Hotstar and Prime, you get another 50 hours each. Look at Twitter, LinkedIn, Instagram, put them together, you get another 40-50 hours. Limit your WhatsApp. WhatsApp is probably one of those inevitable things which you can't probably kill completely, nor can you do to email. But amongst these places, you can find 250 hours. Last 8 tips for IP Math. We'll do a separate session, Cube 7. This one, let's attack this. I've seen that question, Suman Kumar. Gap year hurdle. In my next gap, I'll jump in for that. And how many ways can distributing 15 identical balloons, 6 identical pencils, and 3 identical erasers among 3 children? Each child gets at least 4 balloons and 1 pencil. And so, child 1, child 2, child 3. And how many? What do we have? We have 15 balloons, 6 pencils, and 3 erasers. Each child gets at least 4 balloons, 4 balloons, 4 balloons. Nice. The balloons are identical. Actually, we don't have to pick anything there. And 1 pencil, 1 pencil, 1 pencil, 1 pencil. So we have accounted for in some way 12 balloons and 3 pencils. They go in there. While I was doing this question, I'll look at it and say 4 balloons and 1 pencil, 4 balloons and 1 pencil, 4 balloons and 1 pencil. I'll put it in. So 12 balloons are gone. Remaining is only 3 balloons. 3 pencils are gone. Remaining only 3 pencils and 3 erasers. So if I were given with this task, I'll say give this off, keep them happy. Now let me process this. They're all looking at their balloons and pencils. They're very happy. Now I'm saying, look, I have 3 balloons, 3 pencils, and 3 erasers with me that I have to distribute to 3 children. In how many ways can I do this? And so let me think about the 3 balloons part. Then I'll worry about the other things. And so 3 balloons. How do I do this? I can say, hey, 003. That works. 2 zeros are there, or 012. Or 111. So if I have 2 of them getting nothing, all 3 going to 1. That's possible. Or 1 of them gets nothing, the other 2 get 1 and 2. Or all 3 of them get 111 each. Nice. Brilliant. So 003 is one possibility. All 3 balloons go to the same child. 012 is one possibility. One child gets nothing, the other 2 get 1 and 2. Or 111, each of them gets 1. The 003 can happen in 3 ways. Why 3 ways? 003, 030, 300. And one moment you write it like this and you're saying, look, are these 3 different? Do I need to worry about all 3? Then you need to go back to the funda and saying, child 1 gets 0, child 2 gets 0, child 3 gets 0, child 3 gets 3, or child 1 gets 0, child 2 gets 3, child 3 gets 0. Are these 2 different? Of course they are different. You have 3 balloons. Giving it to child 3 or child 2 or child 1 This is a big difference. It's potential World War III or not difference. If you have dealt with children, you will know what I mean. So these three are very different. Sometimes we stop and think, do I have to count 0, 0, 3, 0, 3, 0 separately? Go back to the context. 3 children. Child 1, child 2, child. Sometimes people ask me, do we assume the 3 children to be identical? I'm like, dude, think, pause, process what you're asking. There are 3 children. If there are balloons, I need to tell you whether they are identical. Children, no, not happening. So you don't have to worry about it. The question will not make that clear into 3 identical boxes. Yeah, boxes I have to worry about it. 0, 0, 3, 0, 3, 0, 3, 0, 0. You have 3 children getting 3 different combinations of balloons. Of course, 0, 0, 3 is different from 0, 3, 0. Why? 0, 0, 3 means child 3 gets 3 balloons. 0, 3, 0 means child 2 gets different balloons. Or you want to be super clear, call this as Ram, Geeta, David. You give 3 balloons to David, it's very different from giving 3 balloons to Geeta. Yeah, I get it. So anytime you go to hit that block where you say, look, do I have to worry about 0, 0, 3 and 0, 3, 0? Define, name, go to the context, come back, distribute the damn balloons. And so now coming to the 0, 1, 2. It can be 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, 2, 0, 1, 2, 1, 0. 3 factorial ways. This can be done in 6 ways. 1, 1, 1, that can be done in only one way. The balloons are identical, 1 to each person. Done. That can be done in only one way. Or 10 ways. What have we got so far? We've got that the balloons can be distributed in 10 ways, which is nice, but we're not done. We need to distribute pencils and erasers. You come this far and say, look, have I done only 1/3 of the question? No. We've done 99% of the question, because we're effectively distributing 3 balloons. It can be done in 10 ways. 3 pencils, 10 ways. 3 erasers, 10 ways. Total number of ways, 10 into 10 into 10 equal to 1000. This 0, 0, 3, 0, 1, 2, 1, 1, 1, where we have done this, and then 10 ways totally. I know some of you are thinking this guy is just taking us on a wild trip. He doesn't know this formula, n plus r minus 1, cr minus 1. See, we can do that. Effectively, this question boils down to p plus q plus r equal to 3, where p, q and r are whole numbers. This can be done in 5C2 ways, just 10. I just want to do this question without necessarily having to know that. Sometimes knowing that takes away the whole funda of what are we doing here? I'm distributing 3 balloons, not 43 balloons to 7 people. 3 balloons. It can be 0, 0, 3, 0, 1, 2, 1, 1, 1. 3 ways of doing this, 6 ways of doing this, 1 way of doing this. 10, done. I don't even have to do the horrendous n plus r minus 1, cr minus 1. You don't need, we could do that. It is correct. It is possible. And it is doable. You don't need to know even that. Fine. So 10, 10 and 10 and 10,000. Beautiful question, challenging question, but notwithstanding all that, still doable. Fine. Om saying, what is wrong in thinking the way the first balloon has 3 options, 3 into 3 per 3 for balloons, and similarly for pencils and erasers, the balloons are identical. The first option, balloon taking the option of going to child 1, second one going to child 2, or the other way around, the same. Balloon 1 and balloon 2 are identical. Child 1 and child 2 are not. Balloon 1 and balloon 2 are identical. When that happens, we can't do 3 into 3 into 3. Magnificent. Let's go to the next question, which also is challenging. At least I think so. Oh yeah, nice and challenging. Give it a go. Suman Kumar asks, gap year a hurdle in the way of admissions into any B school? Yes, it is. Indeed. Your B school admissions happen with 5 variables. And so, very important, simple 5 variables. Class 10, class 12, undergraduation, CAT score, work experience. I'm putting it like this because everybody has these 3 generally before CAT. Big part of those variables are not in our hand. This some people have, some people don't. This is still in our hand. The weightages of each of these depend on which of these IIMs that we are looking at, or which of the universities, which of the colleges we are looking at. These are the 5 variables that go into the pot. Right? So, if you have a gap year, these are the 5 that go into getting a call. If you have a gap year where there's a gap between 12th and UG, or UG and work experience, or somewhere there is a gap, then it does not affect your criteria for getting a call. Where it could affect you is in not having work experience. Where it could affect you is on the interview seat, where you have put in your application that you have 30 months of experience, but your undergraduation, ending of undergraduation to landing up at the interview part, this is a 72-month gap. I'm going to ask you, look, 3 years are missing, could you fill us in? And then you say, look, I tried this, I tried that, I tried my own thing. If what you tried is convincing, meaningful, you're good. If it's not, if it's just, look, I was just chilling, then it makes an issue. Nalin Surya understood the first method, really didn't get the second one. Don't worry about it. The second one is done in great detail, even on our own YouTube channel. I'll be able to find the link and post it for you there. Put it on comments. I'll find the link and post it right now. Obviously, my hands are tied. Put on a comment saying, look, what is the second method in this question? I'll find you the relevant link and put it there. We've gone to the second one in some great detail on our blog, website, and on YouTube. I'll see if I can find that and put it there. You can just go through that a couple of times and that should be fine. Lovely. This is once again a challenging question. All the questions that appeared in the last CAT, permutation probability, were super challenging. 1 year prior, that little bit easier. A 4-digit number is formed using only the digits 1, 2, and 3, such that both 2 and 3 appear at least once. And so, the number of all such 4-digit numbers is super. First of all, I'm going to think about the 4 digits. Then I'll worry about arranging them, rearranging them, and all that. The digits can only be 1, 2, and 3. No 4, 5, 6, 7, no 0, nothing. Simple. And each of them, 2 and 3, appear at least once. I have 4 boxes here for myself. 2 sits here, 3 sits here. 2 and 3 are in. I'm effectively worrying about only these 2. Nice. This can be 1, 2, or 3. This can be 1, 2, or 3. But if I just count it as 9 different possibilities, then my problem is there could be some repetition sitting there. So what am I going to do? I'm going to list everything. Only 9. It's not rocket science. So what am I going to say? 2, 3, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. 2, 3, 1, 1. Yeah, that works. I'm going to write that down. 2, 3, 1, 2. Yeah. 2, 3, 1, 3. Yeah. 2, 3, 2, 1. 2, 3, 2, 1 and 2, 3, 1, 2. I'm effectively counting the same thing. Remember, I'm just doing only the digits. Now I'm getting the hang of this. 2, 3, 2, 2 will get counted. Yeah. Let me put that in there. 2, 3, 2, 3 will also get counted. Yeah. 2, 3, 2, 3, 2, 3, 3, 2. There is an issue there. 2, 3, 1, 3, 2, 3, 3, 1. This I'm not going to count because I've already counted this. 2, 3, 3, 3. Oops. That will go on. There are 9 here. 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. These 2 are 2 and 3. Remember, I'm not saying the first 2 digits are 2 and 3. After the 4 digits, there is already a 2, there is already a 3. I could have 2 2s and 2 3s. A 2, a 3 and 2 1s. 2, 3, 1 and the 4th digit being 2. All of those different combinations. That's what I've written down here. Differently thinking about it, 2223, 3332. So two possibilities. 2213, 2313. There are two types of things. 2311, 2233. This is separate. This is separate. And so this is different categories of digits. Now what do? We need to find, with 2311 being the digits, how many numbers are possible? That is 4 factorial by 2 factorial, which is 12. This is 4 factorial by 2 factorial, which is 12. 4 factorial by 2 factorial, 12. 4 factorial by 3 factorial, 4. 4 factorial by 2 factorial by 2 factorial, 6. 4 factorial, 4. Once you have listed all this down, after that it's just a matter of plugging in that formula. Super tough question. So 2311, 2312, 2313, 2322, 2323, 2333, 2223 and 3332, 4 numbers each. 2233, 6 numbers. 2311, 2213, 2331, 12 numbers each. 12 plus 12 plus 12, 36, 40, 46, 50. Totally 50 numbers. Super challenging question. Right. Wonderful. I'm going to go to the next question. There's a link available to download all these questions as question format, so you can download them and then go ahead and discuss that. So the link is given in the chat window, 2MCAT preparation. So have a look at that. Look at that and just kind of see for yourself all these questions in one go. How is 2312 and 2231 same? 2 2s, a 3 and a 1. All numbers formed like this. So 2312 and 2321. This is to answer Nandita Singh's question. 2312 and 2321. So 2312 and 2321. This is, if you rearrange this, you have 2 2s, a 3 and a 1. 2 2s, a 3 and a 1. Effectively, all the rearrangements are going to be identical. First thing I'm thinking only the digits. Only then I go to the numbers. First we think about, worry about the digits, then we go to the numbers. Try this. Good question, challenging question. Nalin Surya, can't we set 2 and 3 in different positions and proceed further? You can, but it gets confusing, Nalin. I'll tell you why. Because if you put 2 and 3 in, say, second and third positions, and then you put one more 2 in the first position, and I'm going to do this, discuss this. Very interesting idea. Suppose I put 1, 2, 3, 4. I put 2 and 3 here, and then try to count all possibilities, and I managed to do that. And then one of those possibilities says a 2 here. This will be same as 3 and 2 here and 2 here. I'll have to worry about double counting and triple counting and God knows what else. So when you're creating a mechanism to count, not only should it be robust that I'm counting every distinct possibility, there should be no overlap. If there's an overlap, I'm dead. So if I put 2 and 3 in these positions and I count everything, then I put 2 and 3 in these positions and count everything, I end up double counting, and that's a problem. We've got to be very careful with that. Right? Why is 2312 same as 2321? Dhruv Agarwal, we have just answered that. I'm just listing the digits. The numbers I count finally separately. And both of these will be counted among the numbers, only not in the listing of the digits. That's the place where I'm not counting it. Product of the digits is more than 2 but less than 7. What can the product be? More than 2 be 3, 4, 5, 6, but less than 7. 3, 4, 5, 6. 3-digit numbers. Product is more than 2 but less than 7. 3 is prime. I'm thinking about 311. And all arrangements after that. The moment I see 3 is prime, I know that 511 also is similar. Done. The moment I do this, I know I can have 411 and 611. I'm not saying that's it, but 411 and 611 have to be included. 4 can be written as 2 into 2, 1, 2, 2 also comes in. 6 can be written as 2 into 3. I don't know if I've counted everything, but I'm going to dive deeper and then I'll think about have I counted everything. The digits were 311. How many numbers are there? 3 numbers are there. Why? 311, 131, 113. 3 numbers here, 3 numbers here, 3 numbers here. 411, 141, 114. 511, 151, 115. 611, 161, 116. Done. In the bag. 12 numbers like this. Beautiful. What about 122? Oh, beautiful. 122 also there are 3 numbers. 122, 212, 221. What about 231? 231 there are 6 numbers, 3 distinct digits. 123132, 213231, 312321. So I've got 3 plus 3 plus 3 plus 3, 12, plus 3, 15, plus 6, 21. Now I'll pause and say, okay, it seems to be right. 3 and 5 cannot be written anyway. 411, 5, 611 I have in the bag. They have to get counted. 4 can be written as 2 into 2, apart from just 4. 6 can be written as 2 into 3. Nothing else is there. I don't have to worry. 21 it is in the bag. In all of these questions, it is super useful to think in terms of let me get the digits in first. Then I'll worry about how they can be rewired. Nice question. Give it a go. Tough. The mean of all 4-digit even natural numbers to form AABB, that A is greater than 0. Just having a look at the chat. Nothing new in the chat, so we're all good to go. Mean of all 4-digit even natural numbers to form AABB. Nice, AABB, even numbers. So what should BB be? It can be 00, 22, 44, 66, 88. Nice. What can AA be? 11, 22, 33, 44, 55, 66, 77, 88, 99. Anything AA cannot be 0. So what are the numbers we have? 1100, 1122, 1144, 1166, 1188. 2200, 2222, 2244, 2266, 2288. 3300, 3322, etc., 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 etc. All of these. How many numbers do we have? 9 into 5, 45. You have to add all of these numbers and divide it by 45. That's it. We're through. Nothing dramatically new there. But it's a pain, right? Add all numbers with 1, 1. All of these. So add all of this up. Add 1, 1 into 5. That's a sum. Add all of this up. Add 2, 2 into 5. That's the sum. Add all of this up, 3 into 5, that is the sum. And so you have to effectively combine all of this and get to the answer. The thing is, they're not asking us for the total, they're asking us for the average. I'm waiting for somebody to grab onto this. I must tell you that I did not get the funda in the exam. I did the brute force way. I found the sum of everything in different combinations. About 75% down the way, I kicked myself and said, look, this is a super juicier method, and then reverted to the better method. Quite simply, for a second, forget all of this. Only 1 1 is there. I'm taking 5 numbers: 1100, 1122, 1144, 1166, 1188. I'm taking the average of all of this. 1100 is common. After 1100, I have 0, 22, 44, 66, 88. Average of these 5 numbers is 44. Or think about this: 1100, 1122, 1144, 1166, 1188. Average will be 1144. Why? Minus 22 plus 22 minus 44 plus 44. 2200, 2222, 2244, 2266, 2288. Average will be 2244. These 5 numbers average is 44. Flip the other way around: 1100, 2200, 3300, 4400, 5500, all the way till 9900. Average will be 5500. What's the overall average? Beautiful question, delightful question. 45 different numbers, you add all of them and get 45. It's a pain. Or you can think of this as 1100, 2200, 3300, 4400, 5500, 6600, 7700, 8800, 9900. Each of these comes 5 times. And then 0, 0, 2, 2, 4, 4, 6, 6, 8, 8. Each of those comes 9 times. Add everything up, divide by 45. Or I'm effectively taking the average of these, which is 55. Average of this, 44. 5544 is my answer. I'm done. Beautiful question. You can grab onto the idea. Look at these 2 numbers. Find the middle one. Find the middle one. Write the answer. We're through. Effectively, that's what we're doing when you're doing averages. And so, beautiful question. Absolutely delightful question. I did it by the brute force method, where I calculated everything, then simplified, used fancy techniques to simplify life in the simplification process. But if you just looked at this and looked at the average, middle number, 5544, give me the next question. You could have done that. And that would have been the guys who just have a flair for this, they do that. And they get that right. If you don't power through, you'll still get the right answer. Don't worry, another minute, not going to be a killer crime. But having a good sense to spot that, good, hats off to them. Lovely, 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 lovely. Several of you appear to have got this funda. I'm going to go to the next one. Yeah. Try this. Interesting question. This is the kind of question which is technically I wouldn't count it like a counting question. But hey, stick it in, it's there, therefore we try it. No. It is one of those, it's not really permutation probability as much as it is algebra. But I had to include even this to get to around about a question and a bit per paper. So this counting or permutation probability combinatorics is not such a heavily tested paper, not heavily tested section. One question is generally there. Sometimes it's a cheating one question, something like this. But usually it is less than or equal to 2. One is definitely there. The second one may or may not be there. Number of pairs of integers x, y satisfying this in all of these questions. Simple rule of thumb, find 1. 1, and then we can work from there. 2x plus 5y equal to 99. Find one value that works, and then you're through. 2x is an even number, so 5y should be an odd number. Then this will work. put y equal to 1. X is, the total should be 99. So y gives us 94, x should be 47. Nice. 47 into 2 plus 5 into 1 is 99. Nice, brilliant. After this we are through, effectively through. Why? If 47 and 1 works, then if I add x, I'll have to reduce y. If I reduce x, I'll have to increase y. That I understand. My total is 99. If I increase x by 1, my total increases by 2. If I increase y by 1, my total increases by 5. X should be offset by y. Or if I go from 47 to 42 and I go from 1 to 3, it should work, because I increase this, decrease this by 5, twice of that is 10. I increase this by 2, 5 times that is 10, plus 10 minus 10, giving me a total of 99. That's my funda. This x changes by 5, y changes by 2, one will offset the other. X drops by 5, y increases by 2, that will work. So 47 and 1 works, 42 and 3 works, 37 and 5 works, 32 and 7 works, 27 and 9 works, 22 and 11 works, 17 and 13 works. Somewhere along the line I'll check. 27 into 2 is 54, 9 into 5 is 45, yeah, that works. 22 into 2 is 44, 11 into 5 55, that works. All of these work. Now let's look at the constraint x greater than or equal to y greater than or equal to minus 20. Nice. The next number, this becomes 12, this becomes 15. 12 into 2, 24, 15 into 5, 79, 75. From here onwards, I don't have to worry, because x becomes less than y. 17, 13, after that it doesn't work. I go the other way around. So what have I counted? 47, 1, 42, 3, 37, 32, 27, 22, 17. 17, 13 is included. What do I do here? 52 minus 1, 57 minus 2. What can I go till? Sorry, 52 minus 3. 57 into 2, 114. Minus 15 is 99. Yeah. Minus 1, minus 3, I can keep on going. Y greater than or equal to minus 20 till minus 19 I can go. So minus 19, minus 17, minus 3, all the way, this many combinations are possible. Find one, know how you can work from one to the other. X goes up by 5, y should go down by 2. X goes down by 5, y should go up by 2. Write in one direction, write in the other direction, then count. So now all of these combinations are possible. I'm going to look at y. Y can take minus 19, minus 17, all the way to plus 13. Minus 19, minus 17, minus 15, all the way till minus 1, 1, 3, 5, 7, 9, 11, 13, 1, 2, 3, 4, 5, 6, 7, 7 in this side. Minus 1 to minus 19 is like 1 to 19. First 10 odd numbers with a negative sign. 10 here, 7 here, 10 plus 7, 17 numbers. It's more an algebra question than really a permutation combination question. How do we do this? Find one solution. Done. We've got one solution. After that, think about change in x, change in y. One should offset the other. We find that pattern. Then keep filling out numbers in one direction and then fill out numbers in the other direction. Methodically count, we are through. Time consuming, not easy, but doable. 17 possibilities totally. Wonderful, wonderful, wonderful. I think a few of you have got 17. Not an easy question, reasonably challenging one. Let's go to the next one. Try this. While I take some questions here. how many 4-digit numbers, each greater than 1000 and each having all 4 digits distinct, are there with 7 coming before 3? Four-digit numbers, each greater than 1000 and each having all 4 digits distinct, 7 coming before 3. Right? All of these questions I really like to see one number. And so 7, 5, 3, 4. And so 4, 7, 3, 0. Nice. Look, nice to just see the number. So this number has all 4 digits distinct. And it has 7 and 3 for sure. 2 of the digits are given. And we need to worry about only the other 2. The other 2 can be anything from 0 to 9. Right? Or could they be anything from 0 to 9? This is where it gets very interesting. Could there be anything from 0 to 9? Think about that. Maybe it cannot be anything from 0 to 9. Maybe it is 0 to 9, maybe it is not 0 to 9. Something to worry about. A nice challenging question. This number definitely has 7 and 3. It definitely has 7 before 3. So you can even say, okay, I'm going to put in all the 7, 3 fundas. 7 can be here, 3 can be here, 7 here, 3 here, 7 here, 3 here. Nice, right? Done. What else can happen? You could have 7 here, 3 here. What else could be there? In other words, out of these 4 slots, select 2 for 7 and 3. It can be done in 4 C2 ways. 4 into 3 by 2, 6 possible numbers. Why only 6? Why not 12? Because 7 comes before 3. After I select the 2 slots, I have to put 7 before 3. I cannot put 7 after 3. And it is 7 and 3. So 7, 3 and 3, 7, I don't have to worry about. Digits are distinct. There would 7 coming before 3. Build on this. I don't want to rush through and give you the answer. 7, 3, what can this value be? What can this value be? 10 digits totally. So this can take any value from 0 to 9 except 3 and 7. 8 possible values, 7 possible values. 8 into 7, 56. 8 into 7, 56. 8 into 7, 56. So 56 numbers, 56 numbers, 56 numbers. What happens here? This is 1 to 9 except 7 and 3. 7 possibilities. This is 0 to 9 except 7, 3 and whatever sitting here. Again 7 possibilities. 7 into 7. 7 into 7. 56, 56, 56. 49, 49, 49. Beautiful question, really challenging. Out of the combinations where 7 and 3 occupy 2 slots, we'll have to worry about the numbers slightly differently. Ones where the leading digit is 7, therefore 0 comes into the fold. But the leading digit is not 7, in which case we still have to worry about the leading digit not being 0. Something to still worry about there. So 8 into 7, 8 into 7, 8 into 7, 56. 7 into 7, 7 into 7, 7 into 7, 49. 56 into 3 plus 49 into 3. 168 plus 147. Beautifully challenging question, absolutely brilliant and super difficult, super tough. And so 315, I'm going to go over the whole process one more time. What do we do here? We know the two digits out of 4. We know the 2 digits out of 7 and 3. So we know that number like this will get counted, number like this will get counted. 7 and 3 are in. 2 digits out of 4 we know. 4C2 we can select the slots. 6 ways we can select the slot. We select the slot, 7 and 3 automatically place themselves. 7 comes before 3. That's done. So 7 before 3, 7 and 3 place themselves. I can have 7 and 3, 7 and 3, 7 and 3, 7, 3, 7, 3, 7, 3. Done. So one beautiful distinction between this and this. Here 7 is in the first digit. So other digits can have 0. Here 7 is not in the first place. That means we'll have to worry about the leading digit not being 0. We're talking about 4-digit numbers, which more than 1000. Therefore, this not being 0 needs to get accounted for in some form. That is why this 56 and that 49 are different. 56 into 3 plus 49 into 3, 315 totally. Beautiful question, but super challenging. Super challenging. Lovely. Let's go to the next one. Beautiful question. Give this a go. We'll discuss this once again. I'm just going to trawl through our chat thing to see whether there's some question that I've missed out. Before just download the questions, discuss the questions can be discussed on the link given there. It'll be given in the chat window and should also be there in the description. So you can check out all the questions in one shot, have a look, discuss them, and try them with pen and paper before hitting this video. So please do take time out and check that. The first bit that is sitting there as a description, in the description you can check out that link. You can download the link and see what is sitting there and then take it from there. This question, actually a simpler question. Right? There's a nice, wonderful method of answering it. How many integers in the set 100, 101, 102 till 999? There will be 900 numbers in this list. Have at least one digit repeated. So we're looking at numbers like 226, 644, 979. We're also looking at numbers like 444, 555. Digit repeating. 1 and 2, 2 and 3, 1 and 3. At least one digit repeated. Same digit can come thrice. These are all numbers that we want to count. Or we don't want to count numbers like 345, 678, 970, 165, where the digits are distinct. Several of these questions become super favorable, super convenient if we change the definition. Instead of saying, look, I want to count these, you can say, look, I don't want to count those below. These buggers, I don't want to count them. I don't want to count them. I know there are 900 totally. We can reorient this question of saying, look, I don't want to count these fellows. This question becomes simpler. Instead of saying, hey, what do I want to count? If we can rejig this and say, hey, what don't I want to count? It becomes easier. Subhajit, can we count 7 and 3 as a single number, determine all possibilities and divide by 2? No. He's not saying 7 and 3 come right next to each other. He's just saying 7 comes before 3. 7530 will get counted. 7 is ahead of 3. He's not saying 7 is the immediate preceding digit to 3. That's not what he's saying. But be super careful there. So this one, 900 we know. Total number of numbers is 900. I want to think about numbers A, B, C, where the digits are distinct. A, 1 to 9, B, 0 to 9, except A, C 0 to 9 minus A and B. 9 possibilities here, 9 possibilities here, 8 here, 9 into 8, 81 into 8, 648. Out of a total of 900, we knock off 648, 252 remaining. That is the 252 we are interested in. You can of course go step by step, 1, 1, 1, 2, 2, 2, 3, 3, 3, eliminate all of that. And then 1, 1x, 2, 2x, 3, 3x, eliminate all of that. 1 dash, 1x, 1, 2 dash, 2x, 1, 2x, 2, 3x, 3, eliminate all of that. And then come to this point. Doable, very time consuming. Far better to say 900 totally. From that, I'll subtract all numbers whose all of whose digits are distinct. And then we are done, we can simplify after that. So number of 3-digit numbers where the 3 digits are distinct, 648. Knock that off from 900. We got ourselves a 252 through. Bhumika, but can we do the previous question as total possibilities by 2, as half will have 7 before 3 and half 7 after? That works. But for the total possibilities, we're going to come back to this method, Bhumika. So I see what you're saying. But for the total possibilities, we're going to count like this. 7 and 3 or 3 and 7 and count individually only. We can do it, there's nothing wrong, but you're effectively going to do the same approach all over again. Aman Singh has said 243. Chances are, Aman Singh, you've missed out numbers like 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, all the way till 9, 9, 9. Those 9 numbers have to be included. Be careful about that. Lovely. Let's go to the next question. How many of the integers 1, 2, 3 all the way till 120 are divisible by none of 2, 5 and 7? Not divisible by 2, not divisible by 5, not divisible by 7. Suman Kumar, can you tell me some interesting reading materials which help me in VRC preparation? Bharat's reading list is the mothership, and Bharat's reading list is really the big deal. So go after that. You'll get like tons of high quality reading, not the odd book, but tons of high quality reading. Give it a go. This question can be done in multiple ways. One is with the brute force set theory way, which is basically A union B union C is A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. Number of multiples of 2, number of multiples of 5, number of multiples of 7 minus number of multiples of 2 and 5, 2 and 7, 5 and 7 plus 2 intersection 5 intersection 7. Find this entire giant number. That set is the number of elements that are not multiples of 2, 5, that are multiples of 2, 5 and 7. Subtract that from 120, we should get the answer. And that is one method. And so I'm going to see if that is a method that is robust and workable and all that. I'm going to see if we can find a roundabout way of deliberately trying to do it by a different method. And what do? divisible by none of 2, 5 and 7. This number should not be divisible by 2. That is, straight away eliminates all even numbers. So what do we got here? We got ourselves 1, 3, 5, 7, 11, 13, 15, all the way till 119. Okay. How many numbers are there? 60 are there in this list. Brilliant. Now in this list, obviously going to be some numbers that are multiples of 5. So we eliminate them. We kick them out. We kick out numbers that are multiples of 5. So what do we kick out? We kick out 5, 15, 25, 35. So we kick out 5, 15, 25, 35, all the way till 115. 0, 5, 1, 5, 2, 5, 3, 5, all the way till 115. We kick out 12 numbers. We got ourselves 48 numbers. Right. What are these 48 numbers? We have 1, 3, 7, 11, 13, 17, 19, 21, all the way till 119. Nice, brilliant. What do we need to do there? From here, we need to remove multiples of 7, but odd multiples of 7. So what do we remove? We remove 7, we remove 21, 35 is already gone, 49, 63, 77, 91, 119, because 105 is already gone. 7 plus 14 plus 14 would take us to 35, already kicked out, ending in 5. 63, 77, 91 plus 14 takes us to 105, already kicked out, 119, 1, 2, 3, 4, 5, 6, 7, from 48, drop 7 more, 41. Even without the giant set theory method, we can do this. Should be none of 2, 5 or 7, remove all multiples of 2. I have 16 numbers left. Nice, 60 in the hand. Then what do we do? Remove all multiples of 5. 5, 10, 15, 20, all the way till 115. 12 numbers get removed. Very interesting. So we have left with all odd numbers except those ending with 5. From this I need to remove multiples of 7. Odd multiples of 7. 7, 21, 35, 49, 63, 77, 91. I write down all of them. But then I don't really remove 35 and 105. They're already gone. I don't subtract that again. I subtract 7 remaining, go to 41. That's the answer I'm looking for. This method is super robust. It does work. It is correct. So how many multiples of 2 are there? 60. How many multiples of 5 are there? 24. How many multiples of 7 are there? We have to go till 119. 98 is 105 is 15 into 7. 17 into 7. 17 multiples are there. Add this. A intersection B is multiples of 2 and 5, multiples of 10, 10, 20, 30, all the way till 110, 11 of them. Multiples of 14, 14, 28, all the way till 112. 14, 28, 42, 56, 70, 84, 98, 112. 8 of them. Multiples of 5 and 7, 35, 70, 105. 3 of them. Multiples of 2, 5 and 7, multiples of 70, 1 of them. 11 plus 8, 19, 22. 24 minus 22 is 2. 2 plus 17 is 19. 19 plus 60 is 79 plus 1. Give me a second. 6, 22, 19, 79 plus 1, 80. I'm getting 40 as the answer. Let me check this. Give me a second. I'm going to figure this out. Here I get 41. Let me check that. 60, 24, 17 into 7. Yeah. Number of multiples of 10, 10, 20, 30, all the way to 110. Yep. Number of multiples of 14, 14 to 112. Yep, that works. Number of multiples of 35, 35, 70, 105. That works. Number of multiples of 70, only 1. That also works. 19 plus 3, 22. 24 minus 22 is 2. 19 plus 60, 79 plus 1, 80. These are all numbers that are multiples of 2, 5 or 7. Subtract that from 120. What am I missing? Which I need to check whether it's 40 or 41. 41 is right. So something is wrong here. $35, $70, $105, $14, $28, $42, $56, $70, $84, $98, $112. Yep. 10, 20, 30 till 120. There are 12 numbers in this list. Sorry about that. Adding up, we'll get 79. 120 minus 79 is 41. So, sorry about this. 12 numbers in this list. A intersection B is 12. Thank you, Gairik Chakraborty and Manoj. Wonderful. I'm lucky done by this method. I'm happier for it. But then I missed out that I wrote this as 11, 12 numbers, all the way till 120. Fine. Sorry about that. Let's carry on nevertheless. We have ample time. I was a little worried about time. We have enough time. I don't want to rush this. Beautiful question. Absolutely fascinating question. Give this a go. Bharat Manoj Nair, Ankush Patwari, Manoj Kumar, Gairik Chakraborty, many thanks. I think all of you have spotted that I missed at 12. 120 is included. Ranjit Kumar, thank you so much. Om Singh, 12 in place of 11. Yep, thank you. 12 multiples of 10. Maitri Rishi Sharma. Subhajit Datta said, can we find out this, any of the three numbers? Yes, we have done by that method. And I made a mistake in that method. And finally get to claw it back and simplify. Thanks a ton, all of you. Thank you. Just see. Thought I had some water here. I don't. Lovely question. Beautiful question. A into B is 4th power 2017. A into B is 2 square power 2017, which is 2 power 4034. A and B are positive integers such that A into B is 4 power 2017. A is less than or equal to B. Very nice. A is less than or equal to B. What do we do? Generally in all of these questions, I really like to find one value, two values. So A could be 2 power 1000 into B could be 2 power 3034. This works. Nice. The moment we find this, I want to find the extreme condition. What is the extreme condition? A is less than or equal to B. Put A equal to B. A could be 2 power 2017. B could be 2 power 2017. Nice. We told A and B are positive integers. So A could be 1. B could be 2 power 4034. Or A could be 2 power 0 into 2 power 4034. 2 power 1000 into 2 power 3034. 2 power 2017 into 2 power 2017. Nice. Bunch of numbers here, bunch of numbers here. Extreme condition. We just select one number, one combination, write it down. And then find the extreme here, A equal to B. Find the other extreme here, A as small as possible. B is everything. B is 2 power 4034, A is 1. Which we write as 2 power 0. Anything in between will work. 2 power 5 will work. A could be 2 power 5. A could be 2 power 46. A could be 2 power 92. A could be 2 power 2000, 2 power 1729 will work. And so A could be 2 power anything from 0 to 2017 or 2018 possibilities are there. Brilliant question. Super useful question because this is only one prime factor sitting there. If A had been 2 cube into 3 power 100, we are in jail. Having to work between 2 and 3, 2 primes and having which combination will work. It's an absolute nightmare. Only one prime. 2. This is 2 power 4034. A should have only 2s, B should have only 2s. A can have no 2s, B could have everything. Or A and B could have an equal number of 2s. Anything in between works. 2 power 0 and 2 power 4034 works. 2 power 2017 and 2 power 2017 works. Anything in between A and B will be correspondingly the remaining. That will work. 2018 numbers work. Really seemingly difficult looking question, but very doable. This also is a cheating permutation probability question. Not as much a permutation probability question as much as it is an arithmetic and exponents question. Nothing more than that. Fine. Lovely question. Vinay Joseph is saying 0 can't be taken, right? A cannot be 0, but A can be 2 power 0, 1. We're not saying A is 0. We're saying A is 2 power 0, A is 1. That is possible. I think that the distinction you're looking to make is A can't be 0. That's correct. We're not saying A is 0. We're saying A is 2 power 0, A is 1. Lovely. Oh, beautiful question. And it's a wonderful question. Try this. It's also a question that rather unfortunately, rather irritatingly, I mixed up in the exam and I was rather peeved about it. So, n equal to x plus y, 2 less than x less than 10, 14 less than x less than 20, y less than 23. Then how many distinct values are possible for n? Beautiful question. I got hammered by this question, I must confess. I spent such a long time trying to unravel it, and I found the answer, and I was like, why would they give such a difficult question? My gut feel kept saying that, look, there is something simpler sitting here. And I completely missed that something similar. I overcomplicated this question no end. I looked at this question and said, positive integers, x can take values 3, 4, 5, 6, 7, 8, 9. Oh, nice. And y can take values 15, 16, 17, all the way till 23. Oh, nice. Beautiful. No, not 23, only 22. Sorry. Then x plus y is n. N is greater than 25. So I said, okay, x can't. If x were 3, y can only be 22. No, x can't even be 22. So y can't even be 22. So x can't be 3. I removed this. Then I said, okay, let me start with y. If y were 15, 15 plus 4, 15 plus 5, 15 plus 6, 15 plus 9 is 24. Y can't be 15. 16 plus 9 is 25. Y can't be 16. Effectively, fewer and fewer values for x and y. I did all that. All nonsense. Right? So we don't need to do any of that. So just look at these numbers and you're good. N is an integer. N is greater than 25. And so first of all we say, okay, what is the maximum value n can take? What is the maximum value n can take? X can be 9, y can be 22, 31. Nice. N can only be an integer. The maximum it can take is 31. Why? Because x can be maximum 9, y can be maximum 22. 9 plus 22 is 31. 10. So n can take 31, n can take 30. How can n take 30? Remove one from either x or y. 30 is possible. N can take 29, 28, 27, 26. It's greater than 25, so I don't have to worry about all of this. All of these are possible. 1, 2, 3, 4, 5, 6, done. You do it in a matter of seconds. Then the maximum value n can take is 31. If it can take 31, it can take 30. 31 is 9 plus 22. 8 plus 22 will be 30, or 9 plus 23, 21 will be 30. Done. 30 is possible. 29 is possible, 28 is possible, 27 is possible, 26. They're not asking us in how many different combinations of x and y are possible. They're not. And that's what I thought they were asking us in the question. They're only saying how many different values of n are possible. N can go 31, 30, 29, 28, 27, 26. All of these are possible. It has to be more than 25. I don't have to worry. It cannot be more than 31. I don't need to worry about this. 6 numbers, done. So it's a piece of cake. If you can just say, I looked at this question and I started worrying about combinations of x and y. Rather silly of me, I must confess, but that's what I did. and I chased it and tried different combinations for x's and y's and said this value of x, only that y's are possible, only this many y's are possible, all nightmarish things. We don't need any of that. All we got to do is maximum n is 31, minimum is 26, 23 to 31, all natural numbers are possible, 6. Next. Nice question, beautiful question, give it a go. Very nice question, very nicely worded, framed, formed question. Don't worry, I'm not disappeared anywhere. I just went down to get myself some water to drink, something to drink. Beautiful question. I really struggle with questions of this type when people used to give some formula and then say, look, plug this formula, we are through. I never could wind my head around formulae. And so, rectangular axis of coordinates, the number of parts from 1, 1 to 8, 10, via 4, 6. Let's draw this axis. And then 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 8, 9, 10. Nice. We have to go from 1, 1 to 8, 10 via 4, 6 with only horizontal or vertical steps. You can move like this or like this. I can move one step to the right or one step higher up. One to the right, one step higher up. And so I can take a path like this. Or I can go all the way here and simplify that. Likewise from here to here. Now this is the framework. How do we do this? The bunch of books gave some formulae which annoy me. I'm simply not comfortable with the formula framework. And so we need to go from 1 to 6. And so this is the distance of 5 units. 1 to 4 is the distance of 3 units. What am I going to do? I'm going to say each of these horizontal line is h, vertical lines is V, H, V. So I need to have, if I do H, 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 V, V, H, H, V, I can go from here to here. 5 vertical, oops, sorry, I've got it the other way around. I need 5 vertical steps to go from 1 to 6, 3 horizontal steps to go from 1 to 4. So I can say V, 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 and then I put 3 H's somewhere in between. I'm through. That's all I'm going to do. I can do this in any form. I can say, hey, I can do V, 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 V 5 times and then H, H, H. So I'll go all the way here and here. Or H, 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 V, 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 V. Effectively, it is 5 V's and 3 H's rearranged, which is nothing but 8 factorial by 5 factorial into 3 factorial, or 8 into 7 into 6 by 1 into 2 into 3, which is 56. Now I've got the hang of it. Going from 4 to 8, this is 4 H's, and 6 to 10, 4 P's. 1 to 8 is 7 and 9. 3 plus 4 is 7, 5 plus 4 is 9. Yeah, 4 good. This is 8 factorial by 4 factorial into 4 factorial. 8 into 7 into 6 into 5 by 1 into 2 into 3 into 4. 4 into 2 is 8. 2. 7 into 2, 7 into 10 is 70. 56 into 70, whatever that turns out to be. 0 at the end. 7, 6 are 42, 2, 4, 3, 9, 2, 0. Excellent question, challenging question, something that we need to reconfigure a little bit methodically. The way we reconfigure it to say from here to here, bunch of horizontal steps, bunch of vertical steps. So 3 horizontal and 5 vertical, 4 of each. So it is effectively V, 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 H, H, H rearranged. V, 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 H, 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 H rearranged. We're through. Wonderful. Nothing there in the chat. I'm going to go to the next question. Try this one. Again, not rocket science. Technically not really a permutation probability question, but here we are calling it that. Not seeing much on the chat. I'm just worried that something may be wrong. No, good to go. Let's attack this. We're on to which year? Let me just check this. Up to 2019 we have completed. Perhaps it would be a good time to say, hey, done. We take stock and we hit 18, 17 some of the time. 4 papers, 4 questions, 5 questions each. 5 questions totally, we can do that later on. So we can kind of shift this on to answering questions on preparation and then come back one more day to attack these questions. Beautiful question, more algebra than really counting. There's nothing much related to permutation probability here. So how do we do this? We say 105 equals n square minus m square. So it is n plus m into n minus m. This we know. N and m are positive integers. That means n plus m should be a positive integer, n minus m should be a positive integer. This is positive. This has to be positive because it's 105. Or n is greater than m. That much we know. N plus m into n minus m. You can write n plus m into n minus m, the 2 positive integers, multiply to give 105. And we know n plus m is greater than n minus m. Sum of 2 positive integers is greater than difference between them. They are distinct. We know that much. So 105 is 3 into 5 into 7. That's 8 factors. I can write this as 1 into 105 or 3 into 35, 5 into 21, 7 into 15, 9 doesn't divide it, 11, 13 don't divide it, 15 into 7 back here. This is 4 ways. Writing it down. N plus m into n minus 1, m can be 105 into 1. It can be 35 into 3. It can be 21 into 5. It can be 15 into 7. All 4 of them work. N plus m equal to 105. N minus m 1. We can find the numbers. 53 and 52. That will work. 19 and 16. That will work. So 53, 52. Oops. 53, 52. That will work. N is 53. M is 52. 19 and 16 will work. 21 plus 5, 26 by 2, 13 and 8 will work. 13 square minus 8 square is 105. 11 and 4 will work. 11 square minus 4 square is 105. 4 pairs of positive integers, nothing but factorizing a square minus b square, a plus b into a minus b. Simplifying that, thinking about how many ways this can be rearranged in, then we are through. Nothing else. It is not a permutation probability question as much as it is an algebra question. Right. Wonderful. 4 methods. I'm going to see if we have time to squeeze in a few more questions. Let me just see how many questions are there. 4 or 5 more, maybe 1 more, 2 more. Or should we just stop with this? We're into 4:40. I'm going to stop with this. I don't want to rush through and do a bunch more questions. So I'm happy to take questions on permutation probability and how to solve these questions. Generally, as we have seen so far, we've probably done 15, 16 questions. We've done 6 plus 2, 8 slots, or 9 plus 2, 11 slots, 13, 14 questions. So usually we get 1 question. Sometimes we get 2. And when we get 2 questions, generally the questions fall into the category like this, which is more algebraic rather than permutation probability. We're not doing NCR, NPR here, rather than thinking about n plus m into n minus m. The algebra plays a bigger role than the permutation probability idea. And so 1 question per paper is the benchmark for permutation probability. And 1 question per paper is usually, whether it's a 26 question paper or a 34 question paper, it doesn't matter. 1 per paper is the general benchmark. And so, is it an important topic? No. Is it sometimes too tough? Yes. Is it generally tricky and you can't mark the answer confidently? Yes. Is it a lot of fun? Yes. It's one of those beguiling things. It is, if you know the fundas, then it's a lovely topic to poke at. But if you're not super comfortable with thinking about so many different things, and coins and cards back and ties and digits, and you always worry about, are they distinct, is order important or not, is there repetition is happening here, have I considered all distinct possibilities, what does it mean when they say at least 1, at most 7? This is super overwhelming. Chuck it. There are better returns on time invested to be found in percentages, profit and loss, speed, time, ratios, mixtures, allegations, all of that. The entire gamut of arithmetic topic, each individually, is probably going to give us more than permutation probability will. So as far as the competitive exam for CAT is concerned, probably not required. If you're doing IP math, then probably this is more important. If they have not specified positive, will it be 8? No, not 8. It will probably be much more than 8. It will probably end up being 16. 53, 52, 53 minus 52, minus 53, 52, minus 53, minus 52. 4 different possibilities. 4 each will be 16 answers, not 4. This is to answer a question from Suraj. Umar Ali Khan regarding VARC, read away to glory, get some basic practice in VARC. Go through all the previous year questions. Lovely discussion in great detail on our own YouTube channel. So go through them. Previous year papers are really the holy grail. Check that out. They should stand you in good stead. Definitely check out previous year questions. It is super useful for VARC. And read well. There are plenty of reading suggestions that are there on our website. Lots of good books to read, good blogs to read. There's a daily reading list that gets sent to your box practically every day. Definitely click and read that as well. This is Bharat's reading list. If you're not on Bharat's reading list, you have to go to Bharat's reading list. Today, Advice on DILR again, practice with variety. Previous year papers is the starting step for knowing what this game is all about. Get the basics in. Several times I see students doing questions on LRDI over and over again and taking 35-40 minutes for a set, but not bothering to see the more intuitive solution because you've got the answer. So the benchmark time spent is 15-20 minutes. So if somebody is getting it in 12 minutes, then for them the constraints are laying in their mind in a different way and dancing beautifully. So we've got to figure out how to put those constraints in that way, that manner, where it falls in place like that. And that happens when you go through the solutions. So don't look at anybody who doesn't provide detailed, wonderful, thought process based LRDs. I've seen some papers, some solutions, they say there are 5 possibilities that come from it. If you write down all 5, 3 will go away, only these 2 remain, and then those 2 come there. I can't write 5 and eliminate 3. I need to know what approach I can have to have only these 2 remaining. I can't write 5 and eliminate 3. That's not a solution. That's just that's answer key. Right? So you have to go through the solution part in detail to get there. Rahul Dravid, I'm sure Rahul Dravid is going to be mighty unimpressed with that comparison. I'm mighty flattered. Wonderful, folks. I had a good time. We have had a long permutation probability session. But I perhaps stopped short a little sooner. I'm feeling now bad. We're on to only 4:45. I said we would do from 3 to 5. But I didn't want to start a new set of batches, 2018 and 17, and not finish them. So I said, look, 18 and 17, we can always put it together for one more day, one more session. The permutation probabilities, we're going to always have fun. So we will put together one more drill similar to this soon enough and attack 18 and 17 questions for permutation probability online in some form, sooner rather than later. Wonderful. Best wishes. Take plenty of mocks. Reach out to us on any forum on Facebook, Instagram, anywhere. Right? So there's probably a reasonable size recession coming. So be prepared for it. The best way to get out of a recession or handle or weather a storm is to know your fund as well, build your skill sets well. So whichever stream sector you're on, make sure that you're doing really well there. Make sure to prepare for the exams, clear it well. In bad times, having a good CV, good skill set pays off better, massively better. Our daily schedule for CAT cartoon, just put Google 2IM schedule. There's a detailed daily preparation schedule. You can download on the website and go through that. How many mock tests should we give till exam for CAT? The kind of the baseline 25 to 30, 45 to 50 is good. Any more than that, not required. More the merrier, up to a point. 100 and some people say I'll do 85 mocks. Dude, you'll get tired. You can't do a mock per day. You will do a mock per week. Take it to 2 per week. Flirt with 3 per week on the odd week. You can't do a mock every day. So if you're saying I'll do 85 mocks, then for 8 months you're doing only mocks. Not required. DI and LR have equal weightage in exam. There is really no DI and LR these days. It is LR, DI, logical reasoning and data interpretation, or data interpretation and logical reasoning. The questions don't come under 2 different categories. Data-based interpretative reasoning. You can call it some fancy term like that, but they're not separate criteria. So English is better than most are. Thanks a lot for that. Do you also do VRC sessions? Yes, I do. I have dabbled in them. But I can tell you one thing, there's a perception thing. Whenever a quant faculty takes verbal, people just feel he's a quant teacher. He can't be teaching verbal. And I get mighty peeved. Every time I get wound up by someone saying, you're a math teacher, why are you teaching verbal? I go and say, look, I will teach verbal also. But I have a nice handle on teaching math. I think I'm a better math teacher than I'm a math student or a math solver. So, and I don't know whether I have that for verbal. I'm not dug deep enough. So I do dabble in verbal session, but math is home ground. How can I prepare for other management exams from now on? Only thing outside of what you prepare for CAT that is required for other management exams is a little bit of general knowledge and business decision making for XAT. Business decision making for XAT you can bolt on after CAT, immediately after CAT, bolt that on. Very easy to do. General knowledge, so read away to glory, read about what's happening now. So in your reading schedule, where you read books, novels, magazines, blogs, articles, weave in current affairs based things as well, so that you're abreast with the basic events happening around the world. Super useful. The word per book is necessary for the exam. Not necessary, but it's beautiful. I mean, Jatin sings praises no end for this. And generally when Jatin says this book is good, you should take it seriously. So I've bought the book, I've kept the book, I'm guilty of not having read it. I've given it to my son, saying, look, this is a good book, you must read it. He's 13 years old, so you can imagine what kind of weightage he places on book-related gyan given by father. And so it's there. One of us will come around to reading it at some point of time in our life. It's a brilliant book, no doubt about it. Jatin swears by it. Jatin is Jatin Gangwani, he swears by it. And he says it can shape the way you think about words and ideas and paragraphs and sentences. I have read it in the past, way back in the past. It's a beautiful book. Is it mandatory? No. Is it good? Definitely yes. Malik Khan, please explain about score and percentile. Don't worry about it too much. There's a score, there's a normalized score, and then there's a scaled score, and then there's the percentile. Roughly put, all the scores get arranged in ascending order, descending order. The first guy gets 100 percentile, then 99.99, 99.98, and so on. So, depending on number of people, we get percentile. Descending order of rank is percentile, nothing more than that. What is scaling or normalizing? If slot 1 verbal is really tough, the slot 3 verbal is that little bit easy. Then 14 marks in slot 1 will be marked as equivalent to 17 marks in slot 3. We'll have a mechanism to make it equal and work out of that. Cartoon Tamil, what do you do when you're stuck with this topic? Skip it, go to the next. Number of days per topic depends on the length of topic. You should do way more of geometry and arithmetic and less of maybe functions or permutation probability. You get kind of comfortable, you should move on to the next one. You should keep revisiting. If some topic doesn't fall in place, dump it. Build on your strengths. Don't worry too much about weaknesses. How to read that book? Ping us, ping Jatin. Jatin has done a session on how to read effectively and how to go through that. Ping us, speak to Jatin, go through that session. It's lovely. What I can say off the cuff in a couple of minutes will pale in comparison to what he has put together in a nice detailed session on how to read good books. Wonderful, folks. Have fun. Enjoy your Sunday. Have a blast reading and preparing. Do tons of mocks. Those of you who have been kind of half-hearted about this or flirting with the idea of preparing but have not jumped in completely, jump in now, jump in today. Have fun preparing. At any point of time you have the slightest bit of doubt and say, look, I need a place to check out what this is about. Hit us up on 2IM. The website has all the previous year CAT questions with detailed video solutions, absolutely free. The YouTube channel has all solutions and a ton more, all without paying a dime. You can go to online.2im.com, sign up as a user in about 45 seconds and check out content over 20, 25, 30 hours without paying a dime. All of this is for us a sample where you check stuff out and then you say, hey, this is I verify this, and then I say, look, can I even buy this product? So check it out, sample that, and reach out to us whenever you want to buy. Wonderful, folks. Best wishes. I'm signing off now. I'll catch up with you guys soon enough. I think we're going to do way more live sessions than we've been doing that far.